Hi everyone, welcome to my channel. This is Mrs. Anderson, and in this video I'm going to be talking about matrices. And this is actually part 3 of a series that I've done on matrices. And for this specific video, I'm going to be going over how to use a 2x2 matrix in order to solve a system of equations by talking about what the determinant is and also getting into Cramer's rule. So first let's talk about what the determinant is and how it can be used. The determinant of a matrix can help us solve a system of equations if we were given that. Remember that a matrix looks like this, where you have those rectangular brackets on the outside, and inside of the matrix you have elements that make up the rows and columns. So that's where you see my A, B, C, and D. The determinant looks just like the matrix in that the elements on the inside that make up those rows and columns stay the exact same, but notice how my brackets on the outside have changed slightly. Instead of having those kind of curved in rectangular brackets, we have these straight parallel lines. And I've always said to anybody working on a determinant that they're very similar in how they look if you're dealing with absolute values. So if you know what absolute value bars are, they look very similar to what a determinant bar means. The only difference here is the determinant is a process of actually solving for something that, like I'll show you later, can be used to help solve a system of equations. But if they are asking you to find the determinant of a matrix and they give it to you in that matrix form, you can just replace those rectangular brackets with these parallel lines and still follow the rules for finding the determinant. In order to do that, you cross multiply with your elements, so A times D and C times B, and then you subtract in the middle. So I want to show you some examples here where we find the determinant. For this first one I have 2, 3, 1, 6. So in order to find this, I'm going to cross multiply and subtract. So I'm going to take 2 times 6 and 1 times 3 and put a subtraction sign in the middle. You're going to want to make sure that you multiply the elements first before you subtract, so follow your order of operations there. And so we have 12 minus 3, which equals 9. For this next one, I have 4, 2, negative 3, and 7. The setup looks exactly the same. 4 times 7 minus negative 3 times 2. And so I have 28 minus a negative 6. And if you remember, anytime you see a double negative like that, you end up adding it. So it's really 28 plus 6, which is 34. So the next thing I want to get into is something called Cramer's rule. And Cramer's rule is a way to use the determinant that we were just finding of a matrix in order to help you find solutions to a system of equations. So let's refresh what a system of equations would look like. You would be given two equations that are in this form. Ax plus by equals e, and cx plus dy equals f. For a system of equations like this one, the letters a, b, e, c, d, and f would all be replaced by numbers. The only letters that you'll see that stay there would be the x and the y. And I'm using x and y because that's generally what we tend to lean to when we're using a system of equations, but just know that it could be replaced by other letters like m, n, or it could be replaced by an a and a b, but I'm going to stick with x and y for the purpose of this video. Now the reason why x and y stay unchanged is because that is actually what we're trying to solve for in order to state the solution of the system of equations. So let me show you the setup for x and for y using the determinants. If you notice for x and y, the top determinant changes. The x one we have e, b, f, d, and for y we have a, e, c, f. Now the bottom determinant is the same for both of them, a, b, c, d for both. So when I am working with Cramer's rule, I have said that you could always find the bottom determinant first because it stays the same for both equations. You would be able to use it twice. So really the only thing that you're going to have to change is that top one. And all of those letters that you're seeing, the E, the B, A, C, all of those come from the numbers that I said that will be given to you in your system of equations. So you're just pulling that information down, you're plugging it into that form, and then you use what we were just doing, cross-multiplying and subtraction, in order to actually evaluate to solve for those variables x and y. So let's look at an example here. We're going to solve this system of equations. We have 3x plus y equals negative 17, and negative 4x plus 4y equals 28. For this problem, my a is 3, b equals 1, e equals negative 17. Those three numbers all came from the first equation. Continuing on, c is negative 4, d is 4, and f is 28. All of those came from the bottom equation. So this is showing you the setup to solve for x. I think personally that the hardest thing to do is to know which numbers you need to put where, and that's when you just have to go back and look at Kramer's rule that I showed you to see what numbers go in, where does the a go, where does the b go, the e, and so on. For the top we have negative 17, 1, 28, 4, and for the bottom we have 3, 1, negative 4, 4. Once you have it set up in Kramer's rule using that pattern I showed you, solving for the determinant should be fairly simple because you just cross multiply and subtract like we were doing earlier. So I have negative 17 times 4 minus 28 times 1 on top, 3 times 4 minus negative 4 times 1 on the bottom. Now I evaluate, so I have negative 68 minus 28 over 12 minus a negative 4. And that simplifies to negative 96 over 16. Now remember, fractions mean division, so I'm just going to take negative 96 divided by 16, and so I get negative 6. So x would equal negative 6 for this problem. Now this is the setup for y, and like I stated earlier, if you look at the bottom portion of y and you compare that to the bottom portion of x, they're identical to each other. So I just repeated everything that I had from up there. So I wouldn't necessarily have to do all of that work to evaluate it again, but I'm just showing you guys that they are the exact same thing. The top portion has changed because I pulled different letters down using Kramer's rule again. So I have 3, negative 17, negative 4, 28. The process is the same where we cross multiply and solve. So 3 times 28, negative 4 times negative 17, and we subtract. So on top I have 84 minus 68, which is 16. So I end with 16 divided by 16, which would be equal to 1. So y is 1. What x and y represent here, that negative 6 and 1, is if I took those two numbers and I replaced the x and y up in my equations given to you, and I actually evaluated and simplified it, I would get that those balance equations would happen. So I would get negative 17 equals negative 17, and 28 equals 28. For example, if I take 3 times negative 6, that would be negative 18. And then I would add y, which is 1. Negative 18 plus 1 would be negative 17. If I did the same thing for the bottom, I would get 28. Let's look at one more example. X plus 3y equals negative 17, and negative y equals 4. Notice how the second equation is missing the x term. So for this equation, when I go to state my c value, because that's the number that's in front of the x on the second equation, and it's not there, c is going to be equal to 0. So make sure that you still state that, because you are going to have to use that 0 inside of your determinants. So I have x and y both written out up here. Again, you guys can see that the bottom portion is the exact same for both of them. The top is the only thing that changes. So if you went back and you looked at Kramer's rule, I'm just pulling those letters to match that pattern that I showed you, and then I'm evaluating. So for x, on the top, I get 5, and on the bottom I get negative 1. So 5 divided by negative 1 is negative 5. For y, 4 over negative 1 is negative 4. So x would be negative 5, and y would be negative 4. To check that, on the very bottom one, I have negative y, so negative of negative 4, you've got double negatives there, makes that become positive 4, so that balances 4 equals 4. And I could check the top one as well, and I should get negative 17. If you're ready to give it a try, I've created a practice quiz on a website called quizizz.com, and it is a multiple choice platform where you can go and practice the skill that you just learned. The link to that can be found below in the description, but I've also included it here for you to type into your URL if needed. I hope you learned something from this video, and thank you for watching.